What's up everyone, Patrick here, welcome back. Moving on to another question dealing with similar triangles. So a right triangle has legs with lengths of 5 and 12, and then a similar right triangle has a hypotenuse of 65. What is the scale factor between the triangles, and use it to find the area of the second triangle. So let's draw some diagrams here to start. So we have one triangle, which is here, and we are told that it has legs of 5 and 12, like that. And then we're told there's another right triangle, a similar right triangle, meaning that the angles are the same. And that right triangle has a hypotenuse of 65, like that. And we have to figure out what is the scale factor between the triangles, and then we have to use it to find the area of the second triangle. Now, just as a quick review, the scale factor, what we can do is we could take the side of a certain triangle, any side, and then we can multiply it by that scale factor to get the side of the other triangle. So let's call this like triangle 1, and this would be triangle 2. Like that. And then we could also relate the areas of the triangle as well with that same scale factor. So we would have the area of triangle 1, but instead of multiplying the area by k, we'd be multiplying it by k squared, and we'd get the area of the second triangle, like that. Okay, so that's how we can use the scale factor. Now, we have to figure out what the scale factor is. And notice that we could do that because even though we're not given the hypotenuse here, we could figure out what that hypotenuse is here with the Pythagoras theorem because we're given the length of the legs. And then we could see how this hypotenuse relates to this one by what scale factor, right? So to find this hypotenuse first, we would do 12 squared plus 5 squared equals 8 squared. And so we'd have 144 plus 25. And so we'd end up with 169 here. And then we can square root both sides, so we'd get 13. So this here would be 13, this hypotenuse. And so now we can see by how much do we multiply this side to get to this side. So we'd have 13 times the k value, which is what we're solving for, to get the other side. 65. You could also switch these values up, but I personally like to put the smaller side here in order to get a k value that's going to be greater than 1. And so now if we divide both sides by 13 and isolate for that k value, we would end up with a k value of 5, right? 65 divided by 13 would give us a k value of 5. And then notice that from this triangle, we can actually figure out what the area is because we have the base and the height. So the area of this triangle would be base times height divided by 2, right? So 12 times 5 is 60 divided by 2 would give us 30. And so we'd have this area times the scale factor to the power of 2, and that's going to give us that second area. That's going to give us the area of this triangle. So we'd end up having 30 times 25, which would give us 750, like that. So that's what the area of this triangle here would be. Another way that we could confirm that is we could actually use that same scale factor of 5 and find this side. So notice 5 times the scale factor of 5 would give us 25 over here. And then we would have 5 times this side, 12, which would give us 60 here for that side. And then we could do base times height divided by 2, which would also give us that 750. So that's another way to do it, but they said to use the scale factor to find that other area. But there's multiple ways to find the areas. Whichever way you do it, area is 750.